So, first of all, I would like to say that I'm very obliged for your invitation on your conference. I represent simultaneously three institutions. First of all, Institute of Environmental Engineering and Biotechnology, University of Opole, Poland. Then Ukrainian Institute of Microbiology and Virology of the National Academy of Science of Ukraine, and Spanish University Politècnica de Catalunya. And it is obvious that the main direction of our investigation is integrating thermodynamic prediction in the development of the environmental and bioenergetic microbial technologies. Our strategical approach, combination of thermodynamic prediction and microbial metabolism regulation to obtain the desired environmental and bioenergy effect simultaneously. Based on thermodynamic prediction and all multifunctional microbiological biotechnology were developed. This technology enabled rapid and efficient degradation of dangerous solid waste, combined with production of a clean energy carrier, such as hydrogen, and finally, simultaneous reductive removal of soluble toxic chromates and other metals from wastewater, resulted in the formation of insoluble, non-toxic, and simultaneously high-cost concentrate of chromium-3 hydroxide. What does it mean, thermodynamic prediction, and what is the main idea of thermodynamic prediction? It is to determine the conditions necessary for microbial destabilization of a toxic compound to obtain non-toxic one by shifting pH or redox potential EH in the desired direction. On this picture, one can see the zones of thermodynamic stability soluble compounds of chromium-6 in the coordinate of pH and redox potential. And it is obvious from this picture that decrease of redox potential lead to forming reductive form of chromium-6, chromium-3 hydroxide with irreversible precipitation. So we must use this thermodynamic prediction to find the best metabolic pathway to precipitation of chromium-6. Here you can see the thermodynamic prediction of anaerobic degradation of ecologically dangerous solid organic polymers. The optimal conditions for the hydrolysis, that means degradation of a wide range of solid waste and further hydrogen fermentation, is low redox potential equal minus 415 millivolts and pH equal 7. And to optimize this process, we applied aerobic bacteria as bioreductant. And this applying gives the possibility to decrease the redox potential in the zone of optimal for the hydrogen fermentation. Next problem. Strong shift of pH in negative zone, in negative value at the hydrolysis and further hydrogen fermentation of plant and animal polymers. So we use soluble certain pH buffers to compensate this negative change. And finally, it is obviously that on the surface of solid particle concentrated the toxic and metabolites, products of fermentation. To avoid this problem, we applied intensive mass exchange, that means mixing. So due to this, we obtain suitable engineering, technological, and ecological parameters. I would like to emphasize that in the best biogas modern technologies, the time detention of substrate is close to 30 days. In our biotechnology, this time detention is no more than 6 days. And next effective result. In biogas modern technology, the coefficients of degradation, that means the ratio of initial mass of waste, solid waste, to final, not more than 30 times. In our experiment, the maximal coefficient of degradation is more than 500. And simultaneously with the degradation and fermentation of solid waste, we obtain the ecologically pure energy source, such as molecular hydrogen, close to the 40%. Next problem. Detoxification of toxic soluble chromo-6 compounds. We analyzed more than 100 reactions with chromium compounds, and only one reaction was suitable for the microbial detoxification. It based on the reduction of chromium-6 compounds to insoluble chromium-3 hydroxide. And from this diagram it is obviously that the most successful process will be in the case of the large difference between the donor system, for example, hydrogen producing anaerobic bacteria, and high potential chromate with standard redox potential plus 555 millivolts. Here you can see the thermodynamic confirmation of effectiveness of these two combined reactions. Low potential donor reactions, that means hydrogen fermentation anaerobic, and high potential acceptor reactions, that means the reduction chromium-6 to insoluble chromium-3. And really large difference in redox potential, close to 1000 millivolts. It is the basic for effective reductive precipitation and detoxification of chromate. However, an insoluble problem arose. High potential chromate with a potential more than 500 millivolts strongly inhibited the growth of low potential anaerobes that need minus 415 millivolts. Here you can see the limit in chromium-6 concentration. It was not higher than 30 millivolts. But we discovered a novel approach. The applying of phenomenon of redox locality and phenomenon of redox gradient. What does it mean? Here you can see the sequence of grading of redox locality on the example of whole potatoes. The anaerobic bacteria penetrate inside the whole potato, reduce the redox potential, and synthesize low potential and reductive metabolites. And due to the explosive synthesis of gases, the mixture of carbon dioxide and hydrogen, we obtain so-called redox gradient of low potential reductants, metabolites. And due to this, we obtain the forming zone of bacterial contactless chroma reduction by powerful flow of redox metabolites. It is very impossible to understand that here one can see the creation of contact-less zone with chromates. It means that is never mind what is the concentration of chromates in these solutions. And here you can see the confirmation. It was necessary only 16 hours to complete precipitation of chromate in a wide range of redox, chromium 6 concentration from 100 ppm to 1000 ppm. And here you can see graphical confirmation. So here you can see the representative model of contactless zone of reduction. In zone of redox gradient synthesized low potential reductive metabolites. And further step, the reduction, fast and effective reduction of toxic high potential chromium compounds without contact directly with microorganisms. The powerful protective flow of reductants from a diversified microbiome should enable detoxification of a wide range of metals in any concentration range. And here you can see a general confirmation of precipitation, different mechanism of precipitation of a wide range of metals in zone of contactless. Here you can see the reduction chromium 6 with precipitation of zinc due to the forming of carbonate of zinc, and the next sulfides of insoluble 2 cations. So let's summarize our result. Creating universal environmental and bioenergetic microbial biotechnology that gives the possibility, first of all, solid waste degradation, hydrogen synthesis, ecologically pure source of energy, obviously purified water, and due to the reduction, microbial reduction of chromium 6, one can obtain concentrate of chromium that is a suitable high-cost product for the further involving in industrial processes. Thank you very much for your attention. This is our team.